Okay, great. Well, thank you all so much for joining us for another webinar. We're so happy to have you all. And yeah, it's a pretty good turnout, 30 folks. So we are a manufacturer's rep firm, L3. I'm Michael McClellan. We also have Billy Sanders on the line with us. Billy has actually done one of these projects, one or more of these online monitoring projects at a paper mill in his territory. And maybe towards the end, he can tell us a little bit about how that went. L3 has a controls division and a power division. We give back to the industry to make it better and safer for all. And we've been doing these webinars almost daily since the pandemic outbreak. So this presentation is in webcast mode. That means your phones are muted. However, we would love for you to interact with us. There is a button, should be on your left side, that is I believe it's a magnifying glass or a question mark, and press that button and you can ask a question of our speaker, and they will try to answer that either immediately or at the end of the presentation. So there, you may see some poll questions, so pay attention. And with that, I'm going to turn it over to the guys from Dynapar and let them introduce themselves.
Yeah, good morning. Thanks, Mike. This is Mark Langell with Dynapar, and I'm the manager for the condition monitoring system business. And with me is Derek Lammel. Derek, do you want to go ahead and introduce yourself?
Hello, my name is Derek Lammel. I'm a Cat3 vibration analyst working here at Dynapar. I work with Mark closely on the remote monitoring side of the business.
Thanks, Derek. So I'll just go into a little bit of the topics we're going to cover today. And as Mike indicated, questions are welcome, and we'll try to keep close tabs on time and try to leave room at the end for you guys to bring in some additional questions that come up. I know that there's always, bottom line is everybody's plant systems are unique, and that's what we're trying to do here is tailor a system for where you guys are at, and bring in great groups like L3 to act as our partners. And we'll get through the presentation and then take questions. So key things that we're going to talk about today are how remote monitoring integrates with route-based vibration monitoring, how field service vibration technicians in a particular use case helped a major food producer prevent downtime. Likewise, in a packaging material manufacturer, how they prevented severe failure from a damaged bearing. And then we'll step back a little bit and then take a look at some of the guidelines that we recommend for customers to use to how to prioritize their assets for monitoring. And we'll try to give you some thought processes and a framework around how to get started and things that you may encounter from your organization as you go through implementing a condition monitoring system. Everybody hear me okay? Okay, good. So first thing is, many companies, and this isn't all companies, it really depends on where you come in at, may or may not already have a route-based vibration monitoring program, right? Where someone comes in, they create a number of points on each asset, they create sort of an efficient path, they create the route, they'll do some loading of the route into their handheld monitoring system. They do initial equipment setup, take data, transfer the data, do a historic view, and then do a data analysis and reporting. And from that, right, they're going to identify equipment at different levels of, quality and in their total asset life. And so, really what you are looking for is something that is known as the PF curve, which talks about the likelihood of failure and where your particular piece of equipment is on that curve. and they could be looking for things, gross defects like misalignment and looseness, and imbalance, things that are can be potentially, hopefully, a little bit shorter term or longer term, which are bearing faults, and even electrical faults will be things that they would register and see on that route. The key is, and everybody in manufacturing and production with rotating equipment knows that you're never in a completely static situation. And so with fast changing conditions, there are some times when, in terms of being able to conduct route, you may not be able to get back around to a piece of equipment to understand or see that change of state. And in the example that that Billy may go into from L3, that's kind of exactly the situation that arose. So, but the bottom line is, with remote monitoring, you can set up the sensors, install in the equipment, and then on a periodic basis, hourly, daily, even minute by minute, if necessary, if you're doing troubleshooting, the data can be read in, and then a remote technician or a technician locally anywhere in the building can take a look at that data. And then instead of having to make the analogy I like to use is, instead of making a house call, which how many doctors these days make house calls, you have, let's say, remote telemedicine, the ability to have your data analyzed. Okay, so the bottom line is, and depending, again, we want to meet you guys and help meet you guys where you're at. So you may be on the end of not having anything at all. You may already have route, or you may have a full-fledged IoT implemented system. And both of those approaches, both route and a full online condition monitoring system, have their pros and cons. Route obviously can't provide you the continuous element of it, but there is a labor content that's involved. And then on the IoT side, you may not find that from a ROI perspective, it makes sense to deploy sensors on every single asset down to, a quarter horsepower vacuum pump, and smaller assets like that. So because from a cost perspective, it may be cheaper to, have those on hand, and you've got good distributors who are able to get you the components that you need in a timely fashion. So we view that there's a balance and a spectrum and an arc, right, of the story, where customers go from completely reactive, just always replacing stuff, maybe before it's due, maybe they have lots of high cost downtime, all the way to, running perfectly, always catching things before problems exist through a combination of route, and then really to improve things and bring you to that high uptime capability through implementation of an IoT-based monitoring system. So just to give you a little bit of viewpoint on the Dynapar on-site system, it essentially constitutes two pieces. One, the hardware piece, 4 sensors, input capability for encoder, wireless, easy to add, and then the analytics package, which gives dashboarding, full-on vibration analysis tools, easy interface, and as well allows for that multiple stakeholder involvement. So I think the other key thing here is that, the vibration data can tend to be a data silo where it's the domain of only the vibe analyst. And part of the intention of the Dynapar on-site system is to allow the kind of innate intelligence that the larger maintenance team has about their equipment, for them to begin to have those kind of higher level tools, from the trend graph to FFTs to time waveform, and things like that. We'll go into exactly what that means. But the bottom line is, nobody knows your equipment better than the local stakeholders. So the Dynapar on-site system allows that kind of knowledge to be meshed with vibration technician capability at any time to really begin to understand, what could potentially be driving downtime. Okay, so with that, I'm going to turn it over to Derek, and Derek's going to go through a couple of use cases that we've had, and going to be able to get into the details of vibration analysis. Okay.
Good morning, everyone. Thank you, Mark, for going through that with the on-site system, I want to talk about some successful case studies that we've had. Next slide, please.
Derek, stay in the mic. You're kind of faded out there.
Next slide, please. All right, the following case study was performed on a rooftop blower unit. The unit routinely failed between route-based vibration inspections, which caused unscheduled downtime. With the operational commitment of production, the ability to perform maintenance was a challenge. Next slide, please. Next slide, please. Thank you. During a route-based inspection, an anomaly was detected on the fan bearing. The customer sought the expertise of a field service technician for a solution. The customer wanted to know exactly how bad the bearing defect was and how long before maintenance could be extended. Now, the field service technician turned to Dynapar's on-site remote monitoring system as a solution to extend scheduling maintenance when production and maintenance was flexible. Next slide, please. The data depicted here shows the progression of bearing degradation as monitored by the Dynapar on-site system. On day 10, the time waveform and FFT analysis showed running speed harmonics present, indicating internal looseness and bearing wear present, verifying the vibration data during the route-based inspection. By day 44, heavy impacting is present in the time waveform, and running speed harmonics in the FFT has increased in amplitude, indicating the need for bearing replacement. Next slide, please. The timeline shows the progression of the anomaly detected. On October 7th, the problem was detected by route-based vibration inspection. Based on the tight production schedule and the inability to shut down the rooftop blower, customer relied on Dynapar on-site system to extend the time period to schedule maintenance until necessary and install the Dynapar on-site system on October 17th. On November 3rd, the bearing degradation worsens and a work order is written to schedule replacement of the fan bearing. On November 28th, the bearing is replaced during a scheduled maintenance shutdown. By having the ability to take vibration data daily, the customer was able to extend the bearing life for an additional 53 days. Next slide, please.
So we've got, I think we've got a poll question here. So let's see here. I'm gonna.
Okay, so Mark, I've just launched the poll.
Okay.
And let's give everyone about 30, 45 seconds to vote.
All right, great. Thanks, Michael. This one is, how many times last year did you have an unscheduled outage, right, on critical equipment that was difficult or costly to replace?
Give it another 30 seconds.
Okay.
Would you like me to share the results, Mark?
I pulled them up here. So looks like majority of people have zero unscheduled outages. Looks like 20, the 1 to 3 is the 20%, and then 5 to 10 is the next highest. Okay. Good. So it's a number of people, you know, are doing some great things out there where they don't have any unscheduled downtime. Michael, anything to add?
No, I've closed the poll and proceed.
Okay, very good. Thanks. Derek?
Next slide, please. Thank you, everyone, for answering the poll. I'd like to talk about one more case study that we've had. This case study was on a rotary screw compressor motor failure, which was critical to production. The motor had previously catastrophically failed and caused a major unscheduled downtime event. Due to operational commitment, the company had to rent an air compressor while parts were on order, which was a 2-day lead time. The determined final cost of this downtime was $65,000. the customer decided it was time to take predictive measures and prevent the downtime from occurring again. And by installing the Dynapar on-site system remote condition monitoring system after the motor was replaced. Next slide, please. After the initial installation of the motor, an anomaly was detected via recently installed remote monitoring condition system. The anomaly detected was an outer race bearing frequency on the compressor motor. Being able to detect the defect early, the customer was able to secure and schedule a bearing replacement by continuously monitoring the motor's condition. Once the bearings arrived, the replacement of the motor bearings as a scheduled maintenance event prevented much unwanted downtime and provided a positive return on investment as compared to the prior catastrophic failure. Next slide, please. Looking at the trend analysis, the top image, the primary vibration analysis tool, which indicates when anomalies start to occur. As you can see on the left, during normal operation, the vibration amplitudes are stable. As time progressed, on August 15th, the amplitude of vibration increased, indicating bearing defects were present. There are 3 images below the trend analysis, known as the fast Fourier transform, or FFT, looking from left to right, shows the progression of the bearing outer race defect frequency. Additionally, the bottom images, known as the time waveform or the raw data signal, shows the progression of how the amplitude and impacting increased just before replacement. Next slide, please. So how can you maintain production while monitoring trouble assets in your facility? Answer, simply get started and deploy quickly. Next slide, please. The first step is to build a product program. Do a full audit of all your rotating equipment to identify which assets are ideal for remote condition monitoring. Categorize your equipment by the highest priority group or class. So how do you choose? Next slide, please. Identifying assets from facility audits should be the following classes. Next slide, please. Identifying the pilot project starts with auditing asset classes by the following 3 conditions: risk of failure, impact of failure, and duration of downtime. Our risk of failure is to consider the environment or access is difficult, or the regularity of maintenance or history of failure. Our impact of failure, consider if a piece of equipment fails, will multiple processes be affected, resulting in major downtime? And the duration of downtime, consider assets that have a long lead time for parts or specialized equipment required for doing replacement downtime, such as having to secure cranes or any kind of other specialized equipment that's not at your facility. A great tool for choosing these assets is by using a risk assessment matrix. Next slide, please. Looking at this slide, group assets into classes and consider a similar analysis in your facility and rank the assets based on a high, medium, and low priority. As you can see, blower motors have a high risk of failure, a high impact of failure, and an excess downtime, duration of downtime, which is an ideal candidate for remote condition monitoring. Next slide, please.
Okay, we've got the next poll question coming up here. And this question is around kind of directed towards people maybe that don't have program already going, but it could as well be sort of think about it as where haven't you implemented an online system where maybe you have wanted to. So what prevents you from implementing a vibration monitoring program? And then I'll just add a little to its fullest extent. Wait just a little bit longer for a few more votes, everybody. All right. Great. Mike, I think that's probably good there. Or you want to give them a little more, give everyone a little more time?
Okay, I've closed the poll.
Okay, good. So feedback on that looks like about better than half of the people have not been able to justify the CapEx and train staff. And then second most answer is we prefer to handle this house, but have not found the time. So feedback, and we will maybe address a little bit both of those items. So thanks everybody for your input. We appreciate it.
Thank you everybody for your input. Mark, next slide, please. Thank you. Looking at this slide, common examples of high priority assets for condition monitoring are cranes, typically because of their difficulty and access and criticality. Compressors, if a compressor fails, it may shut down an entire plant. Air handlers and blowers typically are difficult to access on rooftops, especially in the wintertime. Conveyors, which the failure of just one motor can halt production throughout a whole plant. Pumps, which are critical to process and cooling. I thank you for taking the time, and I will ask Mark to continue where I left off.
Yeah, thanks, Derek. Before I move off of this slide, one of the things that I find, and wanted to relay, Dynapar's experience thus far. I would say that the difficult to get to is likely probably 90% of the assets that we end up using on-site onto. So many of the assets have that element to it. So, and typically what happens, can happen in application is that those items that are hard to get to, remote, maybe there's some safety concerns, don't get monitored with the frequency that they need to. And one of the strengths of the Dynapar on-site system is that it doesn't require really almost any infrastructure locally to get up and running. So you don't have that startup cost that can be typical of online monitoring. And then in addition, we are able to merge that data back with production and control data so that it looks and feels seamless from a infrastructure and from the rest of the data infrastructure that you have at a particular location. Okay. So, I'll go into a little bit of what you should look for and pulling back a little bit in a remote monitoring system. So one of the things is, really comes down to time, which was, talked about in the poll, something that's easy and fast to install, that you can get data quickly from, provides a high level of flexibility. Rich data tools for analysis so that you can really discern how bad the problem is. I feel like there's a good number of people who are pretty well, have a good understanding of vibration based on the high amount of people who have zero problems. But, just in case, right, the analogy that I like to use, and again, I kind of go back to the medical one, which is, ultimately you can get your lab results back, you can get an EKG result, you can get your X-ray in, but having that trained person to take a look at the data and really give you the feedback on how bad it is provides a lot of value. And that's really, that's where the value is created, is having that actionable intelligence about whether you need to do something or not. So having that rich data and the analysis tools gives you the ability to make those decisions. There's a lot of systems out there right now that provide you what looks to be vibration data, but not with the analysis tools and not necessarily with the data accuracy that you can feel comfortable with in making decisions. So kind of moving on to that next point, having that data accuracy gives you the ability to really believe in the analysis and those frequencies in the spectrum, and allows you then to make the decisions that you need to. Something that from a cost justification perspective, makes it easy to justify for just one asset with no infrastructure. So kind of out of the box, ready to go. Sensors, software, all those things make it easy to get going. And then redeployable to other assets. And then the ability to integrate that data with your larger infrastructure helps not only, let's say, the maintenance technicians take a look at the data, but even the machine operators, right? If they can see that data, now you're really getting the whole closed loop around how is our system operating. I'm not going to talk in depth about the system, but basically the Dynapar on-site hub and then 4 sensors allows you to deploy this hub to any particular piece of asset, any asset or any equipment. One of the unique things about the Dynapar on-site system is it does have an input for encoder speed or prox probe or laser tac. The key element here is the speed that your equipment is running at is an important data point that a technician uses in order to understand how things are changing. And for variable speed equipment, you always need to know that data. The Dynapar on-site system provides you a way to obtain that. And then in addition to those key features, we've built in a good amount of robustness into the system. Stainless steel sensors, fully potted, robust cable back to the hub, the ability for the hub and the sensors to withstand 80 degrees C and the sensors themselves up to 105 degrees C. So really it's lived up to every application environment that we've thrown at it. And then the last couple things here are the ability for the unit to have an edge trigger. So a local operator can hit the button and decide that things aren't running quite right and they want data to be read into the system, as well as the ability for the unit to self-trigger based on a threshold level, or obviously the unit can take data at regular time intervals. Okay. Last piece here, product-wise, and again, I would use this as guidance for things to look for. We value the input from the maintenance professionals and the vibration professionals, and we've tried to bake in all these tools. So, but it's something that we hope that you guys will do evaluation on yourselves. But what I like is something sort of in it for everybody. So top level dashboards and trending, detailed time waveform and FFT analysis, and then really one of the main things here is a very customizable alarm panel for the vibration technician to be able to impute what they know about equipment into the alarm panel such that it helps close the loop overall for everybody who has access and is tied into the system. And what you get with that in totality is a system that's easy to deploy. It's gathering the important data. It's sending that without any additional infrastructure to the cloud. The cloud is you're able to set automated alarms. You're able to access that data from any point. You're able to have that data timestamped so that it can be reintegrated back with the plant systems. And one other important thing that offers is, because we're not using any plant infrastructure necessarily to get the data, it keeps the control network, the IT network, and everything else completely isolated, which, from a security perspective is highly beneficial. And then the full gamut of tools that we provide, again, there's something in it for everybody. If you have internal technicians, they can use the system. If you want and need external technicians, they're able to provide external support. And then over time, customers potentially that have no knowledge of vibration at all and are really looking to get started can build their knowledge because they have the same set of tools. They have the data imputed in the alarms and all the data available. Okay. We've got a last poll question now, just to put a fine point on it. Looking for feedback from the people on the webinar. Are you currently using a vibration monitoring program at your facility to prevent unscheduled downtime?
So that question is actually in the survey when they.
Okay. So do
when they
we
close
skip
out.
over that then at this point? Okay.
Well, after I end the webinar,
Gotcha.
that question will pop up and they
Perfect.
can answer it. So we've got a few questions here from the audience.
Okay. Yeah, it is a great time for questions.
Good. What type of problems with a motor can the remote monitoring system detect?
Derek, I think this is definitely in your wheelhouse.
Yes,
Given
actually, I can hop on this one.
experience.
So the anomalies that we're looking to detect for motors could be anything from unbalance to structural looseness to misalignment to electrical problems, bearing defects. So there's a wide range that remote monitor can do. You can imagine for a route-based analyst to go in, they're coming in once a month to take data, and they may miss something in between that month period. So having the remote monitoring for motors, we can actually catch everything that almost everything the analyst is catching, as long as we're taking periodic data. So you're able to catch everything route-based is able to catch.
Yeah, one of the things, Derek, I'll add on that is we've even had people that have looked to add vibration data as almost another input in terms of control. So, or let's call it maybe even, like setup is a good example. We had a punch press operator catch a defect. So we were monitoring the rotating equipment really mainly for bearing defects and alignment and such. But in this particular case, we were grabbing some data as well when the punch press was running. And when the punch press was running, we saw a difference in the vibration signature from run to run. And one of them was, basically it looked like you saw 2 hits on the punch press instead of 1. It turned out that first hit was actually the punch die scraping the stripper plate. So alignment wasn't done properly on that. So, in addition to what I would call the classic rotating equipment issues, that vibration data can be used for, kind of other indications about how the process is running.
And another thing to jump into there is with our sensors, our triaxial sensors. So we're looking in all 3 directions at the same time. But importantly, we're getting temperature data, which we've had several customers all of a sudden get spikes in temperature, which is an indicator that there's an issue. So a lot of times you start having problems with windings. They get real hot. Bearings, maybe slower speed. We don't see as much as impacting in the time waveform or anything in the frequency analysis, but the temperature is going up, which tells us there's bearing problems. So there's a lot of things that based on remote monitoring that we can catch that would be simply just overlooked.
Right, and that's why, having both of those data streams is really key. You may see it in the vibration data, and then you kind of confirm where you're at in terms of the PF curve by, are we seeing any indications in temperature, or when do we see both a change in vibration and a significant change in temperature? Okay, that tells you that you're much farther along in the PF curve, and maybe some maintenance action to verify this physically might need to be done. Whereas if you just see an initial peak in the FFT early on but aren't getting that secondary feedback, potentially that you may have more time in terms of when something needs to be done. Okay, I think we certainly have time for a couple more questions.
Yeah, so another question has come in. So who monitors the motors and how is do you get an email? Does that saying, hey, your rotor bearing is about to fail, or what does that process look like?
Yeah, so there is a email and text notification part or field in the alarm panel, and then in terms of so who sets that up and then who monitors it, really we're able to work with the full gamut of possibilities. So one would be you have an in-house vibration technician that would get those emails and maybe do curation of the alarms. We also have the ability to, we have a field service provider network that's kind of nationwide. So depending upon your region, you know, we have Dynapar field service providers. If you have an internal third-party maintenance company that has the vibration technical specialty, those resources can be made available, and you, through the web portal, have the ability to grant access for them to see the data. And then really the fourth way would be, you know, we have internal technicians, Derek being one of them, that can also provide support. But yeah, the first connection is through email or text primarily. And then, like I said, the other option there is the data can be shared with the local domain, the local DCS or data historian. And if they've got a HMI or, you know, screen that they're watching from an operator perspective, there can be an alarm flag notification that's shared with the local DCS. Okay, did that?
Fantastic.
Okay, great. Thanks, Mike.
Okay, here's the next question is, where and how are the 4 probes applied or attached?
I can answer this one.
Yeah, great.
Yeah, so the 4 probes, and actually these are 4 accelerometers. They're digital MEMS accelerometers, and we obviously want to get as close to the bearing as possible. We want to eliminate anything that's hollow. We want it to be on a solid surface, but we would attach it at all 4 points of an asset. Let's say we have a motor and pump. So we're going to put attach either with a magnet. You can use, you can stud mount them, or you can actually epoxy pads on them and attach them with bolt them into there as close to the bearing as possible. So with having the ability to take in triaxial readings, we can place them in the axial direction which is perpendicular to the shaft, and which give us direction. However, it does not matter how we mount them, as long as we know what direction that the sensor is, and we still can determine, you know, what kind of anomalies are occurring, and so they're pretty simple mounts.
Yeah. So in this case, well, I'll kind of flash back through the pictures. This is a stud mount application, and you can see the cast iron bearing blocks or aluminum bearing blocks that are in here were drilled and tapped, and then a quarter 28 fine thread, which is the common convention for US, was used to attach that sensor on the you know, tangential portion of the bearing. Okay, and then as Derek's indicating, on the sensors themselves, we have an XYZ coordinate plane label, so you can have an indication visually as to how things are mounted. So one of the things that we do commonly now to, you know, allow rapid deployment of a system without having to have a technician visit your facility is just getting a quick snapshot of the equipment that you want to monitor, and Derek or external technician can make recommendations on where to mount the sensors, and then that data can be put in, that picture can actually be uploaded into the system, so that as maybe a new technician comes into the fold, they immediately have that visual reference. Okay, I'm talking about, you know, pillow block bearings, and I'm talking about these things are mounted, you know, with a stud tangentially, and then I know the, you know, the XYZ access. So now I can really begin to do the data interpretation. For a temporary or kind of, you know, quick install, we could use the magnetic mounts. And again, those are from getting up and running quickly. When you specify the Dynapar on-site system, you specify the hub itself, whether you want, how long you need the sensor cords, how you want the attachment method, what type of power supply you want, and basically a complete kit comes. The only thing that we don't currently include is maybe a few cable ties for stringing up the cables, but basically everything else is included that you need, including the mounting pads and even epoxy to mount the sensors. Okay. Good.
Okay, great. Next question is, how does the cellular interface handle the volume of data? Is there a bandwidth issue? How would a cell connection tie into the cloud?
Right. Okay. Good question. Yeah, I can tell the gears are turning out there with people. So I'll go through that. So when we use so one of the things that makes Dynapar Onsite somewhat unique is you could think of the Dynapar Onsite hub as an edge computer. So it has the ability to get that data, store that data, and then broadcast that data. And what we do is in the web interface, you have the ability to configure to have the unit take data on an hourly, daily, hourly, or minute by minute basis. And then so normally when we create that initial baseline, we take data at a high rate, once every 5 minutes, once every hour, really to create a snapshot of what that asset does over a 24-hour period or 1 week period. And many times we do a 30-day kind of intensive look at the asset. And then once that's done, you can really back off that interval posting data rate to, certainly once per hour is 24 times per day is a considerable amount of more data than you would typically get in a route-based, once a month or even once per quarter basis. But then on top of that, the unit has the ability to do remote triggering. So basically you set a threshold and say, if the vibration data, either an RMS or peak or even a specific speed is hit, I want the unit to take data. So we have the interval time-based, the edge trigger capability, and then we actually have a third and fourth capability, which is the button that's on the unit, or you have a remote trigger button that's, hey, I just logged into this. I want to know I want to have a fresh data point taken. And so having all four of those capabilities really allows us to minimize the total amount of data that you send up to the cloud, but know that you can get the data needed at any time. And then I think maybe the second part of the question was, how is that data then shared locally? So we have basically a script that can be run locally that would go out to the cloud and pull that data back down. And then the data can then, think about it in just a regular data table, almost like a CSV format, plus the timestamp can be shared with, any of the existing DCS, data historians, OPC server, so on and so forth. So and that's the preferred way for the data locally to be shared. We can, in addition, have an output from the unit that triggers, let's say, a local PLC to trip an andon light or put a warning flag locally. But in the ideal situation, the data would be downloaded via the script and then can be shared, throughout the system. You do have the ability through the web interface, additionally, to just manually download data. And of course, our data policy is that, it's your data. You have that total access to it. You're never, it's never truncated, or you're never prevented from seeing full data snapshot. Again, that's something that I think really sets the Dynapar Onsite system apart from many other cloud data vibration systems, is that you do have full access to the full data and available for download, right, in a number of ways. Okay.
That's great, Mark. Next question that came in is, how is the annual calibration of these sensors managed?
Yeah, good question. So we're using a MEMS accelerometer, and it has certain functions within it that help it maintain its calibration. And then we actually do before every read, we have a internal calibration procedure where we check some internal parameters before the data is taken. And if the unit is actually self-adjusting from that perspective, from a calibration perspective. So at this point, the unit is good for the life of the sensor. and doesn't need any recalibration from year to year.
Great. The next question that came in is, how is the hub powered?
Good question. So we have several different modes. One, the kind of standard starter kit comes with a 12-volt supply that's class 2 rated and can plug into any regular AC power outlet. The unit can also be directly powered off of machine power that may be available. So any power supply, 7 volts to 40 volts, can be tapped in to power it. We do for outdoor applications, we have a solar powered unit. So the unit can be put on rooftop, and yeah, even in the darkest of winter conditions up in Minnesota, the unit was able to be self-powered through solar. And then we also have a version of that, which the unit can run off of a set of lithium-ion batteries internal to the unit for essentially what amounts to 600 reads. So depending upon how many reads per day you're taking, you can divide that out for how long those would last. And then those batteries are rechargeable, and they can be swapped out so that you can deploy a unit sort of temporarily and just go off of battery power to take the data. So those are the 3 main ways that the unit's powered. One thing I just thought of, Michael, is with regards to the cellular connection, we do provide a pre-provisioned cellular router as an option for people to go to. And again, that a lot of times, a first user kit at a facility where they don't want to run the gauntlet with the IT department, we really, we provide that at very low cost for you to do a cellular router.
That's a fantastic idea.
And you have the ability to quickly deploy.
The next question that came in, this is a good one. Can the sensors be submerged? Do you have a probe intended for submersible? He's probably asking about a submersible pump.
Sure enough. So yeah, the units are, the sensors themselves are 100% potted and sealed. So they can be used and rated for, I believe it's IP68.
Did you hear me, Mark?
Yeah, can you hear me? Can you still hear me?
We hear you, Mark. Continue.
Mark, you still there?
Yep.
We hear you. He lost his connection.
I can hear Mark.
Okay, good. So yeah, the sensors are completely submersible and IP68 rated. Okay, seems like maybe Michael is not able to hear me.
I'm sorry, I went on. I muted the wrong device. So.
Oh, no worries. That's okay. Everybody else wasn't bashful, and they just chimed right in. So,
Okay.
Yeah, good. Michael, any other questions?
Did you get the question about the submersible probe?
Sure did. Yeah, IP68 rated, good for submersibility. The stainless steel enclosure, obviously, kind of the gold standard from a chemical resistance perspective. And then the potting compound that we use is, yeah, we found, highly impervious, right, to chemicals. Even the chemicals that are on the, do not use list don't really, aren't effective in depotting the sensors, and they've been used in food grade applications, mills and steel mills and corrosive applications, paint systems, kind of down in then in different types of vault applications where anything and everything is kind of thrown at it. Have had high reliability in all those applications.
Fantastic. Final question, which I think you partially answered with another question, but the question is, how often is the spectrum taken, and how long does the data acquisition take?
Gotcha. Okay, yeah, good detailed question. So we take a full spectrum anytime we do a data read. The data reads are configurable on the web interface, and we basically give customers kind of complete control to take the data. We do have the total limit is that, and you can think about it this way: if you took data 24 times per day, once per hour, and you had, let's say, an edge trigger go as well, we would store up to 3 years worth of that data. So customer could use 100% of their 3 years allotment all at once. We'd store all that data and we continue to store it. We'd have a decision to make in terms of, what data do we archive versus what data points maybe preferred baseline data do you want to leave active at any one time. But 3 years worth of data storage ready at all times, and then stuff that you deem not necessary to have it 100% ready access, we archive, and we can bring that data back up into the data view anytime. Okay, is that it? Does that seem to answer the question?
Fantastic.
Yeah.
Mark, Derek, you guys did a fantastic job. Billy, would you care to add anything?
Yeah, the only thing I think I would like to add is that, these guys, Mark and Derek, are very knowledgeable in vibration. When it comes to actual vibration analysis, Derek has been instrumental with a few of our customers to where we put in, and we have the ability to put in a demo unit at a small cost for 30 days to help over any of those CapEx humps, if you will. Recently, we did have a customer that we put a 30-day trial in for, and during that trial, the motor actually had a failure that was caught by the on-site monitor. Derek was able to log in and see what was going on and actually give some guidance into how to remedy the situation, because it was a belt-driven exhaust fan. So that's something we have the ability to do. If you don't have a vibration specialist or somebody that knows how to read that data at your facility, then we have that ability to be able to help you with that. So feel free to reach out. We can also do some more in-depth lunch and learns if we want to. We do virtual lunch and learns, so reach out, ask questions about that. If you feel like you might have an application, we can discuss that as well. So appreciate everybody being on today, and appreciate Mark and Derek being on and giving us their time.
Well, and Billy, we really appreciate it. And the one thing I would like to say is that, the support that the L3 team has provided has been what I would call best in class from, different partners that we worked with, and specifically Billy, working with, the customers that we've had overlap on. I think, you provide that personal touch for customers, knowing what they need and then being able to bring that to bear. And I think it's a good combination. So thanks for inviting us on and letting us, talk through how we can, potentially collectively help customers.
Yeah, once again, great job, guys. Hope everyone has a wonderful day. And thank you so much for attending another webinar. Hope to see you at another webinar soon.
Thank you very much.